Yes. Hello, college algebra, and welcome to Conics. And today we are focusing on hyperbolas. I don't have a warm-up for you today, but I do want you to check your homework. So if you can take your homework out, that would be wonderful. And kind of look through your answers. You've got some graphing that you were supposed to do, and I realize that this is extremely small for you all. So do the best you can and squint really, really hard. These are the answers to problems 1 through 4. They did write your problems a little bit differently. So kind of my thought process is that, hey, this is an x squared problem and it's positive out front. So x squared problems either open up or open down, but because it was positive out front, we really have that answer. Okay. For problem number 2, it's a y squared. Well, y squared is either open left and right or up and down. Because it's negative, it has to open in the negative direction. So it looks like that. Okay. Let's take a look here at problems 5 and 6. Feel free to pause things as you need to. And then on the back, 7 and 8, you are supposed to complete the square to write things in general form or standard form anyway. And then 9 through 16 gives you a variety of pieces of information, and you're supposed to write your equation from there. And then at the very bottom, you've got 17 and 18. Let me move that a little bit so that you can check your answers. If you can, let's go ahead and save questions, specific questions, for when I'm back in class on Monday. And that way you can make sure that you get things answered well. Okay. Ideally, when you came in, you picked up 2 sheets of paper. Both of them are for notes. And so let's find the piece of paper that starts with something that looks like this page. All right. So what happens when you've got hyperbolas is kind of what we're starting with. So it has a definition for hyperbola, and it's got a picture, and you've got the same picture, which is nice and helpful. If you haven't gotten colored pens, you probably want all 4 colors today. So black, red, green, and blue. All right, here we go. A hyperbola is the set of all points in a plane whose absolute value of the difference of distances from 2 fixed points is constant. Craziness. For an ellipse, we added things together. And when you add, you don't have to worry about positives and negatives. It all added up to be the same number. However, when you subtract, sometimes you can get a positive answer and sometimes you can get a negative answer. And so we have to kind of put this absolute value into play, so that we make sure that when we deal with a difference, we always end up with a positive answer. Okay? So the deal is this. If I subtract this distance, which is D1, so here's a focus again, to a point on the curve, and then from the distance of that other focus to the point on the curve, that's some value. You can pick another point anywhere. Let's pick this point, this green point. So this distance from the focus to the point subtracted to this distance from the point to the other focus is the same amount as it was when I subtracted the blue. You could pick any point you wanted to. Let's pick this point on the right curve. So the point to the focus minus the point to the other focus is always going to give you the same value. Okay, and so that's the definition for hyperbola. Now I'm going to clean this off for a second. And here's the deal. When you're talking about what you're graphing for a hyperbola, it's got 2 parts. Okay? And the other thing you have to kind of understand is that you're going to have asymptotes. And so you do have 2 asymptotes. They're going to crisscross applesauce right in the middle, and that middle point right here is your center. okay? You will have two vertices. There's a vertex, there's a vertex, and you will have two foci. Here's a foci or a focus, and there's the other focus, okay? So a hyperbola is going to have two halves. All right, we have to get into all sorts of definitions. The general form for every conic or for every hyperbola fits this definition. Uh-oh, and this is not so good. Change this, oh, for all, never mind, I'm just crazy. Anyway, so that's your general form. For a hyperbola, the deal is this. A and C are there, but one of them is positive and one of them is negative. So you have two squared terms, and either A is positive and C is negative, or A is positive, or A is negative and C is positive. One of them has to be positive, one of them has to be negative. That's why, or how you know that you've got a hyperbola. Okay, so keeping in mind with the whole positive and negative thing, when you look at this next part that you're supposed to kind of take in, please notice that you've got a subtraction sign here in between. You're always equal to 1. All right. Graphs can go up and down or left and right. So look, over here, X is coming first, and please notice that you're going to be focusing in the X direction. There's a vertex, and then your focus would be inside of there. The distance, it talks about a horizontal transverse axis. This is that horizontal transverse axis that they're talking about. All right. When you have an equation and y comes first and the negative sign comes in front of the x squared, okay, then because y is coming first, you've got a situation where you're opening up and down. And so you've got a vertex, and then your focus is in here and your focus is in here. So all of the major stuff is happening in the y direction. All right. And when you talk about a vertical transversal axis, this is your transversal axis. It just goes from vertex to vertex. Okay. All right. So no longer does it matter whether A is big or little. You have to worry about the subtraction piece. You've got a minus sign here and a minus sign there. And where the subtraction piece is, that's going to determine what your graph looks like overall. We have lots of definitions, but you guys have this picture as well in your notes. Things you need to kind of take note of, okay? This blue axis, it's in blue, is your transverse axis. Half of that, right, is your A value. Half of the transverse axis is your A value. Then you have this other red axis, that's your conjugate axis. We are going to call these 2 points fake vertices. And the distance from the center to a fake vertex is going to be B. You'll have a focus, and just like before, we called foci something about C. Okay? So you've got A, you've got B, you've got C. What's the biggest thing? A, B, or C? Well, I will tell you that C has to be the biggest thing. C is always the biggest thing. And so we're going to have C squared be the equivalent of our Pythagorean theorem part. C squared is the biggest thing. So we'll have C squared equals A squared plus B squared. Man, let's relook at that. All right. Before, for an ellipse, we had A squared plus B squared equals C squared. Or we had A squared equals B squared plus C squared. This time we're going back to this form for a hyperbola. C is the biggest thing, and so it has to be what we're equal to. All right. Fantastic. Moving on. Yeah, we'll move on. So let's talk about some definitions so that we can make sure that we are all talking about the same thing. Okay. Your transverse axis is dealing with the A It's the equivalent of your major axis. It connects your vertices. So vertices are A from the center. Okay? On our conjugate axis, that's going to be used with B. That's going to be the equivalent of our minor axis. And this is where we're going to talk about having fake vertices. I call them fake vertices because you don't actually see them as any point on your graph. They're not really part of it. They are, fake vertices are B from the center. Okay. When you find your vertices, I'm kind of talking in circles here. That's A units from the center. Our foci are C units from the center. They are in the same direction as the vertices. And since C, the distance from your center to the focus, is the largest thing, we're going to have A squared plus B squared equals C squared for a hyperbola, which is different than it was for an ellipse. Okay, here we go. What's A? It's half the length of the transverse axis. Half the length of the transverse axis. Again, it's the distance from the vertex to the center, or the center to the vertex. B is going to be half the length of the conjugate axis. C is the distance from your center to a focus. All right. Asymptotes are going to be there, and asymptotes are going to differ. If we kind of go back 2 slides really quick, you do have 2 asymptotes, and we're going to kind of highlight them in dark, in black. Those are my asymptotes, okay? So here's what I need you to understand. We are going to write these in point slope form. Maybe you should write this back on your slide as well. Okay, so asymptotes are going to be written in point slope form for no other reason but it makes your life easier. Okay, the point is going to be your center. And so I'm going to change that to HK. So y minus k, because for a center k is the y value, equals m times x minus h. Okay, please notice that you have two asymptotes. When you talk about your asymptotes, you're actually going to have a positive case and a negative case. All right. And so what I want you to see is that depending upon how your graph is opening, in this case, to go from this point, this is the corner of what I'm going to call the magic box, this dotted line box, to my center, to this point, I'm going down A over B, down A over B. And so when I do that, it's going to kind of depend upon my graph here. So if my graph opens like this, my slope is A over B. If my graph ends up opening like this, then my slope is going to be B divided by A. And we'll get into that a little bit more as we kind of progress through things. All right. So let's go back to our definition for asymptotes. So I'm going to jump 2 slides up. And so when we talk about our definition for asymptotes, our asymptotes are going to be, well, if the graph opens side to side, we're going to have y minus k equals plus or minus b divided by a times x minus h. And we'll go through that and why it is when we get to that point. If you're opening top and bottom, then we'll have y minus k equals plus or minus, flip the slope, a over b times x minus h. All right, your lattice rectum is still going to be 2b squared divided by a, just like it was before. It's still the width, width, oops, of the graph at the focus. Okay, you're not changing the definition there. It's still the same definition. Okay. So here we go. We're going to graph our first one. So if you didn't have the second sheet of graph or note sheet, then please get that out at this point. This is the first one that we are going to graph. Okay. And so here I go. I'm going to change colors. This has y coming first. And so if y is coming first, my graph actually is going to look like that. Okay. My center is opposite, just like it's always been. So the x value is 5 and the y value is a -1. So 5, -1 is my center. Fantastic. There we go. Vertices. My vertices are going to be found by taking this a value. So a squared equals 25. A equals 5. This is underneath the y value, so we're going to go up and down. So my vertices are up 5 and down 5. 1, 2, 3, 4, 5. There's a vertex. 1, 2, 3, 4, 5. There's a vertex. So those points are 5, 4 and 5, -6. All right, and let's find my fake vertices as well. These fake vertices are going to be found by b squared. So 3 equals b. So let's go with fake vertices. 1, 2, 3. There's a fake vertice. 1, 2, 3. There's a fake vertice. And what happens here is that this creates for me a magic little box that's going to help me find my asymptotes. Okay? I already know, based on my center, okay, that my asymptotes are going to be, let's see, y plus 1 equals plus or minus, and then x minus 5. My center is already there. I just need to find my slope. Okay? Well, if I find the slope, I have to go through the corners of this box. Okay? That's my slope. So if I want to go and come up with the line, I'm going to have to go down 1, 2, 3, 4, 5 over 1, 2, 3. My slope is -5 thirds for this one. Down 5, 1, 2, 3, 4, 5 over 3. 1, 2, 3. Down 5, 1, 2, 3, 4, 5 over 3. 2, 3. And I could keep going and I could go up 5, back 3, but this is an asymptote. All right? And I don't really want all these bubbly things, so I'm going to try to get rid of those as best I can. I don't really care about those. They were there to help me count. Okay. So what about the other asymptote? Well, on this other asymptote, like if I go through it in this direction, I'm going to go, let's see, up 1, 2, 3, 4, 5 over 3. 1, 2, 3. Up 5. 1, 2, 4, 5 over 3. 1, 2, 3. So this other equation is +5 over 3. So moral of the story is that my slopes are the same numbers, but just one's positive and one is negative. So I'm going to get rid of all that green to save myself some time here. Okay, maybe one more. Okay, so to find this other asymptote, I'm going up 5 over 3. I can go down 5, back 3 as well. But my other slope is positive 5/3. So down here, for my asymptotes, I've got 2 of them. That's all they are. Okay, so that gives me kind of the overall kind of boundary lines for my graph. My focus, again, a squared plus b squared equals c squared. My focus on these, the c value is the largest value. So a is equal to 25, or a squared is 25, b squared is 9, and so I'm getting 34 is c squared. So the square root of 34 is c, and if I plug it into a calculator, the square root of 34 is like 5.8. Okay, so my foci, let's see, my focus are 5.8 away from the center. So 1, 2, 3.5.8 is way down here. That's a focus. 1, 2, 3, 4, 5.8. That's a focus. Okay, look, your focus is going to start with your center because I went down and up. I went in the up and down direction when I found my focus. That's changing y values. So when I add something or subtract something, I'm adding and subtracting the y value to that. And so I'm going to change my focus, my exact values for my focus to be those 2 things. Okay. Final thing is my lattice rectum. It's still 2b squared divided by a. So 2 times 3 squared divided by 5 is what we're looking at. That is 18/5, and we decided back when we were doing ellipses that was 3.6. Now remember, we don't want to graph that. We want to graph half of the lattice rectum. So 3.6 over 2 is 1.8. So at the focus, I want to go 1.8 in each direction. So focus 1.8, I'm kind of there. 1.8, I'm kind of there. So you're going to graph through 3 points down here. See the black 3 points? I'm going to go along an asymptote through those 3 points and then along the asymptote again. That's the actual graph of half of it. Go to the other focus. Go back left and right 1.8. And so now I have 3 points. I want to go along my asymptote through the 3 points and then along the other asymptote. So what is in black is the equation I actually want to graph. All right. Let's try another one. Okay. Graph 2. Here I go. X is coming first, so it's going to open left to right. All right. And so knowing that, now we can go and dive into something here. My center is 5, negative 5. So left 5, down 5. There's my center. So my asymptotes are going to be, let's see, a y plus 5 equals plus or minus x minus 5. Look, point slope form is still y minus y1. I'm just using point slope form. That's it. That's all. Okay. Before I can get my asymptotes, though, and my slope, I need to play around with some things first. Where are my vertices? So this comes first. So a squared equals 9. So a equals 3. It's under the x. So that means I go left or right 3 to find my vertices. That's a vertex, that's a vertex. So those are the points 2, negative 5 and 8, negative 5. Fantastic. My fake vertices deal with b squared. B squared is also 9. So b is 3. So 1, 2, 3. There's a fake vertex. 1, 2, 3. There's a fake vertex. Check it out. You just created a magic square. Okay? That means you have something called an equilateral hyperbola because your A and your B values were the exact same number. So there you go. All right. So I've got that. If I want to talk about my asymptotes, look, I want to go through my magic corners. So corner, center, corner, down 3 over 1, down 3. My slope is down 3 over 3. Sorry, I misspoke. Down 3 over, that's just -1. So when you talk about your asymptote here, like look at all these points. All of your points, like they just go straight through all of that stuff. Your slope is -1 here. And if I do the other one through the corners, I'm going to go through that corner, through the center, through the other corner, and it's going to go up 3, over 3, up 3, over 3. So my slope here is a +1. So my slope for my asymptotes is ±1. Fantastic. Let's talk about the focus. My focus is a squared plus b squared equals c squared. I have to find c. So 9 is a squared, 9 is b squared. So 18 is c squared. So that means if I square root it, I get 3 root 2 is my c value. And the square root of 18 is 4.2 on a calculator. So to get my focus, all right, again, x is what's leading here. I have to put a focus inside each of those. So 4.2, 1, 2, 3, 4.2, there's a focus. 1, 2, 3, 4.2, there's a focus. Okay, those are x value changes. I'm changing the x value. So when you talk about your focus, I'm going to start with, my center, which was 5, -5. And in this case, I'm going to change my x value. So that's why I'm going to put that 3 root 2 on the x part of my focus. Last thing we have to do is the latus rectum. Latus rectum is 2b squared divided by a. So it's 2 times 3 squared divided by 3, which is 6. Remember, I don't want the whole latus rectum to graph. I need half of it. 6 divided by 2 is 3. So at the focus, I want to go up and down 3. 1, 2, 3. There's a point I have to graph. 1, 2, 3. There's a point I have to graph. I want to go through the vertex. So I'm going to go along the asymptote through all 3 points and along the other asymptote. Okay. At the other focus, I'm going to go 1, 2, 3 up. 1, 2, 3 down. I have my vertex. Go along my asymptotes, through my points, and along the other asymptote. And poof, we are done. All right. There we go. We're going to do one more together and then see how y'all do at doing it by yourself. Okay. If you remember when we did ellipses, sometimes it didn't have a denominator. And so if it doesn't have a denominator, it's just a denominator of 1. Okay. This has x coming first. So that means it's going to open in that x direction. Okay. And so my center here is -3, 2. So -3, 2 is my center, which means for asymptotes, you've got y -2 equals plus or minus, and then x plus 3. You got to find your slope. We'll deal with that in a minute. Okay. My vertices, well, a squared equals 1. So I'm going to go 1 in each x direction. So there's a vertex and there's a vertex, VV. Ooh, right tiny. -4, 2 and 2, 2 are my vertices. B squared equals 4. Remember, that's for my fake vertices. So B equals 2. So I want to go up 2 for a fake vertex and down 2 for a fake vertex. And the reason we do that is because it creates our magical little box so that we can graph our my hyperbola. Okay. So if I talk about my asymptotes here and I go through the corners of my box, I'm going to go through that corner and that corner. Down 2 over 1, down 2 over 1, down 2 over 1, down 2 over 1, down 2. I can keep going. I can even go up 2, back 1. But there's one asymptote. My other asymptote, if I go the other direction, is going up 2 over 1, up 2 over 1, up 2 over 1. So as a result, when I talk about my asymptotes, my slopes on my asymptotes are plus and minus 2. You're kind of putting that right down here. Okay. Well, let's go to my foci. My foci, again, I'm using a squared plus b squared equals c squared. The c has to be the largest value. A squared is 1, b squared is 4, so c squared is 5. So the square root of 5 is my c value. The square root of 5 is about 2.2. Okay. So again, my focus, I'm going in the x direction. My focus should be inside of my values, or inside of my arcs. So I'm going to go 2.2 on the left and 2.2 on the right. That's my focus. Those are x value changes. I'm changing because I'm going left and right. So my center was negative 3, 2, and I'm going to change going left and right. So I put the square root of 5 on the x value. My latus rectum is 2b squared divided by a. That's 2 times 2 squared divided by 1. So that's going to be 8. Man, that's large. But remember, I don't want the whole thing. I really only want half of it. So I'm going to go 4 in each direction. So at a focus, I'm going to go up 4. 1, 2, 3, 4. Ooh, that's really close. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. So I want to go through those black dots, which are also my vertices. Go along an asymptote, through those 3 points, and along another asymptote. Along an asymptote, through those 3 points, and along the other asymptote. Okay. Let's go to problem number 4. I would really like you all to try this one on your own. So what that means is that you would need to pause the video for about 5 minutes and give it a try and see how it goes. All right, so go ahead and pause the video and see how number 4 goes for you. All right, we're back. Check your answers. If you need to pause and have Mrs. Vivian explain, then go ahead and do that right now, okay? If not, go ahead and flip your paper over and let's look at 5, 6, 7, and 8 so that I can then leave you all alone. Okay, here I go, problem 5. Hey, draw a picture. That's what I keep singing to you. Find the equation of the hyperbola in standard form that has a transverse axis length of 8 and a focus at 0, -5. Okay, so first thing I'm going to do is draw a picture. I'm going to go 8 in each direction. Only because I see this number 5 and I think, maybe that's a good one to kind of go at. Okay, I'm going to start with these. These are tangible things. That transverse axis thing kind of freaks me out. So a focus at 0, 5. 1, 2, 3, 4. This is a focus, and this is a focus. Right? So right there, I automatically know that my graph should look like this because I have a focus and a focus. So I should have something like y minus k squared over a squared equals, minus x minus h squared over b squared equals 1. All right. The other thing I should notice is that halfway between these 2 points is my center. There's halfway between. That's my center. It's 0, 0. All right. And I should also know that my c value is equal to 5. Okay. Fantastic. So really what I've got is I've got y squared over a squared minus x squared over b squared equals 1. Okay. The length of the transverse axis is 8. The transverse axis is the big dog. It's the major axis. So transverse axis is actually 2a, or my transverse axis means that that's a vertex and that's a vertex. That's a distance of 8. A equals 4. So then we go through this a squared plus b squared equals c squared. We're going to use our Pythagorean problem here, a theorem on this problem. A squared is 4. So this is 4 squared plus b squared equals c squared. So 16 plus b squared equals 25. I get b squared equals 9. All right, so there's a, there's b squared. My equation would be y squared over 16 minus x squared over 9 equals 1. Okay, fantastic. Moving on. Find the equation of the equilateral hyperbola in standard form with foci of plus or minus 8, 0. Draw a picture. Draw a picture. Okay. Again, I don't know what the heck that equilateral baloney is, but these are 2 points and they're focus. They're a foci. So that tells me stuff. 1, 2, 3, 4, 5, 6, 7, 8. There's a focus. 1, 2, 3, 4, 5, 6, 7, 8. There's a focus. All right, fantastic. So based on that, whoop, whoop, my graph has to look like that because I have a focus here and a focus there. Wonderful. So that means that it's x minus h squared over a squared minus y minus k squared over b squared equals 1. All right. Halfway between, that has to be my center. Believe it or not, it's 0, 0 again. So I've got x minus 0 squared over a squared. Y minus 0 squared over b squared equals 1. And I know that c has to equal 8. So c squared is 64. Okay. What is an equilateral hyperbola? Well, we had it before, and equilateral means basically that A and B are the same. It was when we had a square, not a rectangle, in the middle of our graph. So A squared had to equal B squared. All right, so here I go. So this is really A squared plus B squared equals C squared. That's our normal Pythagorean deal. But since it's equilateral, I get to say that a squared plus a squared equals c squared. I'm going to use kind of like a system of equations here. I'm substituting it in. Okay. So 2a squared equals 64. So if I divide by 2, I get a squared equals 32. And so a is equal to 4. Well, I need a squared. I don't really care about the rest. And a squared and b squared are the same thing, so b squared also equals 32. I'm done. X squared over 32 minus y squared over 32 equals 1. Okay. If you're stuck, think about this as a system of equations. All right. You know that a and b are the same number. And so I'm just going to substitute out b squared with a, and that's why I did it that way. All right, problem number 7, moving on. Here we go. Find the equation of the hyperbola in standard form with those vertices. Okay, so let's graph it. Okay, so 3, 0. I like to do vertices in blue. So 3, 0 is a vertex, and 3, negative 6 is another vertex. Okay, so that means that this graph has to look like this because my vertices are top and bottom. So this is a y minus k squared over a squared minus x minus h squared over b squared equals 1. Fantastic. Okay, halfway between, somewhere in here has to be my center. What's the average of 0 and negative 6? I know the x value has to be 3. The y value is negative 3. Fantastic. Ooh, I know more stuff, right? Because this is my a value. A has to equal 3. Okay, so I now know that I've got y plus 3 squared over 9 plus x minus 3 squared over something equals 1. Great. Then we're supposed to find asymptotes. Ooh, I like to do asymptotes in red, but okay, find asymptotes. Hey, these are my asymptotes. Negative 6, y equals x minus 6. Okay, so it's negative 6, up 1 over 1, 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 up 1 over, like so. Good deal. Hey, the slope on this is 1, right? Okay. So here's what I want you to consider. I know for sure that this a value is 3, right? A is 3. If I look at the slope, I'm going to have to go up, and then the distance that's going to go to the left and the right is actually b. Sorry, that's a hot mess. But when I talk about my slope here, okay, I'm going to have to go up a over b to find my answer here. Up a over b, up a over b. My slope is a over b. So if I know my slope is 1 and my a value I know for sure is 3, that has to tell me, if I cross multiply here, I get b equals 3. So a is equal to 3, b is equal to 3. So b squared has to equal 9. So I've really got y plus 3 squared over 9, x minus 3 squared over 9 equals 1. There we go. Very good. Last problem, and then I shall leave you alone. Find the equation of the hyperbola, blah, 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 blah. Oh, this one's got gigantic numbers. Look at that, an 18. Gosh, that's just mean. Here I go. All right, so I have a vertex at negative 6. There's negative 6, 18. And then I have another vertex at negative 6, negative 4. Vertex. In other words, this graph kind of looks like this. It does something like this. That's how those work. So I'm opening in the y direction. So y minus k squared over a squared minus x minus h squared over b squared equals 1. Okay, fantastic. I should know stuff though. Like halfway between should be my center. And I know for sure it's got to be a negative 6. What's the average of 18 and negative 4? Right? I basically need the midpoint of those two numbers. So if you want the midpoint, take the average. Average of negative 6 is negative 6. The average of 18 and negative 4 for my y value is, let's see, 14 divided by 2 is 7. So my center is at 7. Sorry, negative 6, 7. So this distance that we just have, these are my a values, is 11. Okay, so a equals 11. So here, I've already got lots of my values here. So y minus 7 squared over 11 squared minus x plus 6 squared over b squared equals 1. Okay. All right. Wonderful. Focus. Oh, there's some yucky things in here. Look, negative 6. So negative 6 means I go back 6. up 7, and then up a whole bunch more. All right, this distance right here that I went up a whole bunch more, that's your C value, and that's just the square root of 265. So C is the square root of 265. Check it out with this other point. Maybe I'll pick a different color here. Okay, let's look at this point right here. I'm going to go back 6, up C, or up 7, and then I have to go down the square root of 265. That's my C value. It's the square root of 265. Again, C is 265, so C squared is just 265. And to find B, we're going to do A squared plus B squared equals C squared. So A squared is 121. I don't know B squared, but C squared is 265. So I got to find B squared. And so I get B squared is 144. So y minus 7 squared over 121, and then minus x plus 6 squared over 144 is equal to 1. Phew. Okay. All right. You've got your rest of the time to work on your homework. Next class, we will review for the test. The class after that, we'll take the test, and then we'll start reviewing for the final exam. All right. That's all I've got for you. Thanks so much. Bye-bye. Bye.